So this workshop is now a simple introduction into an interactive environment. There's two sessions, so we started about doing a really simple one, and we probably don't need 2.5 hours today. But this one is for introducing the concept of interactive environment and giving you a small glimpse of what's possible now in Galaxy if you have interactive environment. So tomorrow we will try to integrate or develop this new interactive environment. Let's see if this works out. Yeah, but eventually today we short introduction. So what are interactive environments of OpenAIs? It's an embedded access to third-party applications. So for example, you've probably heard of RStudio or IPython or Jupyter notebooks. Okay. And these are standalone applications that are awesome on its own. And they enable researchers with programming skills to do a lot on them. So you can analyze an entire RNA-seq in a Jupyter notebook. You have these interactive workaround on your data. You can plot things in a notebook. And with all these features, we are leveraging this Galaxy interactive environments now in Galaxy. So our initial idea was really, okay, I have this great workflow and it reduces my data size from gigabytes or even terabytes to a few megabytes of a table or mostly tabular data set or a GFF file and so on. But now actually I want to iteratively analyze this data set. I want to quickly produce plots. I want to do statistics on top of that. And I'm able to do that because I can program in R and Python as well. And at that time point, at least these advanced Galaxy users were forced to download the data sets, spin up their own environment like RStudio, IPython, or even the shell, and analyze their data there. And we felt a little bit that this is a gap which we need to fill. And this was actually the initial idea of Eric to work on this interactive environment. So our idea was to integrate such interactive analysis workbench in Galaxy directly. Our first idea was IPython, so that point it was still called IPython. But then quickly we iterated over RStudio, nowadays it's Jupyter, but it's the same concept. One point that we needed to solve, that's how it looks like today. So you have your normal Galaxy instance with all these tools. You have your analysis done on the right side. And at some point, as I told you, you want now to program. And this is how it looks like. So you can spin up an interactive IPython instance directly in Galaxy. You can copy data from your history into IPython. You can plot things. So for example, here. And in the end, if you have produced a result, you can save the notebook to the history. So this enables reproducibility. So we store also the code for you. But you can also export the images you have created to the history. Storing notebooks to the history enables to write simple tools for your users. So for example, imagine there's some user that needs a certain tool that is not in Galaxy. So what do you normally do? Either you write a tool and patch it somewhere in Galaxy, or you upload it to the tool shed. That would be the proper way. Or the tool is just 2 lines of code, and that's just to get this user running. So what you currently can do is you just write such a notebook for the user. You can document it, as seen here. So you can really, so you can document. You can document every step And then you can just send this dataset to your user because it's just a Galaxy dataset, as every other Galaxy dataset. And you can share it with users, you can upload it to the data library and tell your user, hey, please take this notebook, run it, insert your data, and then just run my analysis. And in the end, it will produce a dataset in your history, done. Okay, so you can think of interactive environment also as some kind of program that you can distribute without really having it on the left side as a real Galaxy project. Currently, it's not possible to do that in workflow, so this is like an ad hoc version. But as far as I know, the Galaxy team is also working on making it workflow ready, so that these notebooks can also be part of the workflow. Yeah, another example where we also demonstrated that you can install things. So, for example, the first row is installing a tool called MesoPy. So in this container, you have really access. So you can install R packages, Python packages. You can even compile stuff because you are root inside of this container. One problem we needed to solve is because the user is actually quite powerful who uses these notebooks is that the user cannot screw up any data or cannot access data from our histories and so on. Because as I said, you can install tools here. So they could install here a Bitcoin miner and then run it, or some other crazy stuff. So we needed to isolate this environment from the rest of the Galaxy environment. So, and luckily at that time point, this Docker project was born, and yeah, it was just leveraging a complete isolated environment where we could just install an IPython notebook into it. And that's it. So whatever the user is actually doing here is just happening in a complete isolated environment. And as soon as the user leaves the website, the environment is destroyed and all data are installed. So that means that you could install here, or you can remove the entire file system. So you have shell access, just remove etc and var and lib and whatnot. Doesn't care the Galaxy administrator because it's happening in an isolated container. We don't care. Okay, so and that's more or less the concept of an interactive environment. So try to wrap your application in the Docker container so that it's secure, and then we can communicate between Galaxy and the Docker container and exchange material. So in this case, it's exchanging datasets. So we can load dataset with a function that is called get5. Will include the fifth data set. We have a put function that will save a specific data set which you have created back to your history. But also the communication happens between the visualization. So all what you see here is actually hidden in this container. This is also transferred. Yeah, and we needed to solve this stuff. Yeah, in this Galaxy, we were able to do that. This Docker, we were able to do that. Quite interestingly, that enabled a lot more possibilities than we expected at the beginning. For example, there's this great visualization called Penn IO or VCF IO. So these are some projects that tries to distribute a very sophisticated visualization of your reads or your coverage of a BAM file. But it's not a classical visualization because it's quite hard to set up. It needs an own web server, it needs some pre-installed tools. So it's not just JavaScript. So it's a real backend behind it to process the BAM files to be really fast and so on. So it would be quite hard to integrate that locally in the Galaxy instance. So we would include a lot of dependencies on Galaxy. We needed to ship a new web server that is just running this application also. So sophisticated, we would increase the complexity of Galaxy and so on. So this was not the way we would like to go. But with Galaxy Interactive Environments, you just create a Docker container for this visualization. actually the developers of BEM IPython and VCF IPython helped a lot to get this Docker container running, because this Docker container is for general purposes. It's not specifically useful for Galaxy. Everyone can use this Docker container and visualize the BEM files. But as soon as we have the Docker container, we can add a little bit of magic to actually talk from Galaxy to this Docker container. And now we have these kind of visualizations enabled, right, from your Galaxy datasets. And this is the same for variant files. So if you have a VCF file, you can visualize your VCF files as well. So this is a different interactive environment, a different Docker container, and we can talk to them. Yeah. I'm not sure if you are used to these scratchbook. This is just a core feature of Galaxy. So if you click on this icon here, Galaxy is able to open visualizations next to each other. And because this is a core integrated feature, you can also have different interactive environments next to each other. So this is quite nice if you now want to compare a BEM file and then the variant from file that is related to the BEM file. Yeah, that's another screenshot of the BEM IPython EA, which just runs on Galaxy. This project is now 1.5 years old, approximately, and since then a lot happened. For example, this is the Finch interactive environment. This is quite interesting because it is really a community contribution from Saskia Hiltemann. She was participating last year in a workshop where we briefly introduced that as well. And she thought, okay, I'm doing metagenomics, I have this nice Finch visualization. Again, it's really complex to set up. There's a web server behind it and so on. Yeah, and she just contributed. And I would like to highlight a little bit this pull request. So this pull request was merged, so it's now part of Galaxy 16.4. It was merged on the 2nd of February, and there are more or less 4 files she contributed. So this pull request adds exactly 133 lines of code. 4 files are changed, and that's it, what you need to get an interactive environment in Galaxy. Okay, so we reduced from our initial pull request where we implemented IPython quite a lot of boilerplate to make that as efficient as possible. This is just the glue to make Galaxy communicate with Docker containers. Docker container needs to be somewhere, but as soon as you have the Docker container, this is what is needed. So maybe I just go through this pull request briefly, line by line, to just give you the idea that it's simple or complicated. You can decide in the end. I think it's quite simple nowadays, that you get a clue how is it working, and this is what we're doing tomorrow. We try to set up such a very simple interactive environment. So what you need at first is, so we need a config file. So this is just a config file. It's called Finch INI. And all your interactive environments, so if you look at your Galaxy instance, that's a config folder. And then the config folder, there's a plugin folder. And actually, Galaxy supports now 3 different plugins. So interactive environment, visualizations, and tools. Tools. Yeah, we have tools. Yeah, and so let's have a look at the config folder, plugins, interactive environment, and then you will see a Finch folder now. And this is actually in the Finch folder, you have the config directory with just this simple INI file. And what we do here is, actually this just gives you a lot of flexibility from an administration point of view. So you can override your Docker comment. If you have a specialized Docker command, for example, you need to do sudo Docker instead of just Docker, or you have a kind of, you need to add additional arguments, you can really write that down. The most important part is here, where you actually specify the image. So this is a Docker container, which is created, you specify it here, and then it gets automatically pulled down. Galaxy will start up this Docker container, and then they both can talk to each other. All this other stuff is, you can override it, but they have useful defaults. But if you care about security and so on, so you can run your Docker containers on a complete separated VM, so it doesn't need to run on your Galaxy host. Then you use it, for example, change the Galaxy URL or the Docker hostname. But this is very advanced stuff, so just that you know, you can more or less copy this file. Wow, really? So, okay for you? Great. So that's it. Now you have an IPython notebook running in Galaxy. It's a personalized one, so it's just you. You cannot, I mean, this cannot be seen by anyone else. And I will just give you a short introduction how to use this stuff. So, as a normal Jupyter notebook, you can save here a notebook, but this will just save it inside of Docker. If you look to the right, there is some kind of green button, and we indicated it with green, that the green is a history, so green is this button. So this means if you click on this button, this notebook will actually be saved to the history. You have here some options as kernel options. So for example, you can change your kernel. If you are a Haskell programmer or a Bash guy or an R expert, you can change kernels. This is a normal Jupyter feature. So what is probably working is Python 2 kernel, so we stay with that today. And we added two important functions. And we try to explain this function in this help text here, how to use it, because these two functions are more or less what makes this container unique to other Jupyter instances. Because this is how you import data sets from your history and export it. So please have a look at the get function. So get is really just taking a number, and the number needs to correspond to the number of your history items. So for example, you see here 1 and 2, and if you write get 1, and just execute the cell. So you can execute the cell by simply clicking on this run button here. Or there are a few keyboard shortcuts. For example, Alt-Enter will also execute this one. The result of get is always a path. Okay, and this is a unique path to your data set. So what happens now in the background is that the get function actually asks Galaxy, hey, I'm user, which username? I'm user Björn Grüning. I'm in the history first example, and I want to have dataset 1. This is what Docker asks Galaxy. Galaxy says, okay, I have here a dataset, take it. Docker takes this dataset and stores it under import /1. So this is really a path. So let's look at that. If you use a quotation mark, you can use dash comments. So ls-l, for example. Now we look at import. And if you see, you can just type in. You have tab completion in this notebook. You execute the cell. And what you are seeing is actually what you are normally used to from the ls-l output. And if you look closely, you see one file that is called 1. And you see an IPython Galaxy notebook, IPython notebook. This is actually the notebook which you're running right now. So if you click this save button here, it's more or less saved internally. If you do an ls -l on this data set again, you will see that the time has changed. Okay, so this is the get function. We can even look at this at the file. So just use head, import, file 1, execute, and you see that the content of this file, this is a simple text file, and let's look at it. My test file actually contains Chilton. So this is actually what is written here. Because it's the same child. Okay? So this notebook has copied the file with the ID 1 into the Docker container. That's it. But please remember, it's a copy. So if you have here a damn file with 30 gigabytes, could be large. So this analysis is really meant for explorative research. You shouldn't do mapping inside this notebook. I mean, this is where Galaxy comes into it, right?
You can, yes. Don't do it.
We will show you shortly how you install CentOS in this notebook, but why? Yeah. So try to distinguish these two worlds in the sense of all these heavy lifting, this data reduction steps from terabytes to a few megabytes should be done with Galaxy reproducible workflows. If you then want to have an explorative research part with programming, that can be done with notebooks because you can take the text actually to your history. Okay. Any idea what we can do with this file to manipulate it? Here. So we have now changed it. And now I want to put my result back to this. For this, we have defined the opposite of get. So please try to use put. And put this just single. Just put and the path will be defined. Completed. You don't see anything in your history. So that's a limitation we are working on to resolve that. But it's there, you just need to refresh your history. So don't panic if you don't see anything in your history. You just need to refresh it and wait a minute. So we need to trigger that the history is aware of this event. But work on it. Okay, but this only transfers the data set. Okay, so you have created, you have manipulated the data, you transfer back to history. What you now want to do is also you want to save your awesome code here, what you have written. Yeah? So this great notebook, science nature application, ready to save. So click on this green button here, and again, you need to refresh your history. And it saves your notebook to your history. So at this time point, you can close your notebook. Okay, you don't care about your notebook anymore. Because what you have done is you have saved the code you have written, and you have saved the example. So in theory, you can now work on dataset 1 with Galaxy tools. Okay, you can just proceed your analysis. And let's look at this file. I want to leave the environment. Okay, I have my foo file. This is this file here. IPython is gone. I'm ready. At a later time point, I would like to see my code again because I found a bug or whatever. So what I can do now is, this is a special data type in Galaxy. It's called IPython Notebook, which is a special format. And if you click on the visualization button here, click on Jupyter Programming Environment, then something special will happen. So in this case, and only in this case, only in the case where the data type is IPython notebook, the interactive environment tries to start up by but now the interactive environment or Galaxy says, hey, this is the IPython notebook from which you have started. So Galaxy transfers the IPython notebook into the Docker container so that you have not the default notebook, but we actually load now the notebook from the history. That's it. So whatever we have created, so this is what we have done 10 minutes ago. We saved it to the history and we have reloaded it. And now you can just repeat or replay your notebook. This very much reminds me on a video player. And you can just play this notebook. So I can do this. Okay? You see everything is running. So the star indicates actually that it's running. And you see, whoa, processing. It's copying again. So you have here the put comment.
Yeah. Oh, it's just a simple question. Is there a way, I'm not sure if you mentioned it, is there a way to get something into the IPython notebooks that like you have to first give out the number in the history, like someone's got some sequencing data, you want to load that in, but their number is in 10
keywords and servers. So you can do whatever you want on this notebook. So if you get a curl or a wget comment, want to get some GTF files, some annotation files.
But if it's just a different number in the history, do they have to specify themselves, or does the user have to specify it themselves?
Yes, they have to change. Yes. So essentially what we recommend is annotate your file. So what we are actually doing in Freiburg is something like that. At the top of your file, you create such a cell. You specify, hey, it's not code, it's now markdown. Okay. And then explain if you use this notebook, please change the following to the create number to history, something like that, right? And then you define a new cell where you my variable 3, and this needs to be changed by the user. And I hope this is easy enough to be also executed by biologists or someone that is not able to program. But as soon as you do that and you annotate it, you document your stuff, and the user only needs to change this number, just replay the notebook. Yeah, and because we replayed it, there should be a new data set here. Yeah, this one. You see, we just re-uploaded it again. So this is reproducible, and it's coding, and it's in Galaxy. Okay, and this is how also our studio works. Or I mean, the distributor stuff has some nice built-in features that you actually can bridge languages, so you can write R code. I guess Anton will show that, or you can talk from Python to R in one single cell, in different cells, but in one notebook. Yeah. So this is more or less the basic what you should know about this IPython, at least this notebook environment. Okay. Yep.
When you do the plot, how does it recognize what kind of file type it is? Or can you assign a type to it?
If I reload a notebook,
Or when you do the put in the notebook, they can save it back.
the put or the
The put.
Good question. The put has actually a second comment where you can specify content.
If it's not auto detecting correctly. Otherwise, once you lose the auto detection, it doesn't.
When you did the get, could you just type into a variable right off the bat? You know, say like x equals get 1, and then when I did like a open in pandas or something, I probably said x.
So you mean something like that?
Oh, just the right side. Yeah.
So you can do it because what get returns is just a string of your path. So you can right away open it or parse it to find it. Okay, so let's split some notebooks up and just do some fancy stuff in IPython and get used to this concept how we analyze data. So we plan now to do a little bit of IPython introduction in Galaxy. So this will be our first step, and then we will show you real notebooks that were used for analyzing real data and go step by step as possible with this environment and how the connection with Galaxy works. Okay? So we go back to our slides and open this link and import this history. Is this possible? Do you see this history? What I'm seeing?
Do you want them to go to this URL?
Yes. So just import the history. So this should open use Galaxy.org with a shared history.
You go back to the URL.
Yes. So if you copy this, you just take first. Yeah, you can propose. At some point you need to propose. Abdullah, here's URL.
No, you were sending email to all the participants.
Is what? No, the link is just in the slide. Okay. I will use it. Please tell me.
Yeah.
Yeah, that's how you grab it.
Anybody have problems with that? It's impossible to memorize, obviously, so.
This just should demonstrate you that you can really share now code in Galaxy. And those links include some notebooks we just run, which we can now manipulate. And some example data sets.
Yeah.
So just understand what's that? Here, this box where you can change code or markdown.
So the problem is that
You get some simple annotations that you're adding. Where you can write. Then you should execute the cell, and during execution, it's rendered to simple markdown. So the question was, how do I change from a code cell to a HTML cell so that it's rendered that I can annotate stuff. So maybe this is not clear. So every block, so even this one here, is called a cell. It's just that it's rendered differently. So this is just not code, because I have just specified here at the top it's markdown, and markdown is just a code formatting language. But if you change it to code, it looks like a normal cell. Okay, but if you execute that now, it will probably be an error. But if you see here, and now it's just a plain text, it's annotated as markdown, so you always need to execute the cell. So execution means play, and then it will render to your annotation stuff. Okay. So has anyone imported this history and can see this example notebook in the history? Can you open it, please? So it should be more or less look like that one besides this text screen. So it should look like this. Yeah. Okay, so this is what I shared with you. So this is my code. And now you can replay. So try to, this is the first column, and try to just execute. So this is a kind of special magic column which you just need to remember for IPython notebooks. It means that you can directly plot images in this website. So normally something would pop up or it would write to your hard drive some images. You don't want that. You want that images directly in your web browser. And for that you need to have this special annotation. The second column is just Python modules which you import. So this is now programming stuff. You import the pandas module, you import the NumPy module, whatever. Okay? If you are familiar with that, you can change it. Otherwise, you just need to trust me that I send you good code and that you can manipulate your data. So you can execute that as well. Then you have this last column here, which you also can execute. And hopefully you will see at some point an image at the bottom. And now it's integrated in your notebook. Okay, so you can pass it around like I did. But if you want to change it, so if you are familiar with programming, you can just change some variables, annotations, whatever. If you want to do it more flexible, for example, if you don't want that your user is changing actually here some parameters, again, just create at the top of your notebook some annotations, for example, and you can just say here's some variables. So it needs to be meaningful. So A, you can annotate it, you can just comment it. This is my A. And if you scroll down, you could just here in this variable. Okay, so you use does not need to interfere with the code to actually change the behavior of the float underneath. So if you can just do as you want, the outcome should be that the user is able to change these figures, change the small program as you do. Yeah, and then save your changes. Stream it back to your history. You can plot this one to a file on your hard drive and also get the PNG or the PDF back to your hard drive. Yeah, but that's it. Yes.
Can you get the lesson collections and put back the lesson collection? So is it one file or one file?
You have access to the entire IPython API, so if you're familiar with using that, you have access to all those objects and they're pre-configured onto the Galaxy server, put together just convenience methods.
Use 5 blends of Penn, your IPython.
Yes. Actually, that is what it's used to. So if you click on this button here, it's just BioBlend is communicating in the background.
How does it know the authorization space?
It's passed in by the as well.
Passed in where?
When we launch the container, give the container your authentication in terms of an API key.
Okay. So when you do the BioBlend opening, then you already have the keys.
Yep. As you'll notice, the key does not appear anywhere in the notebook, so it is safe to share your notebooks around without worrying about compromising your account.
Where is the one?
It's in Lib Galaxy Web Interactive Environments. Okay, thereabouts. Yes, there we can see.
So we pass these credentials like the history ID, like the Galaxy API key. We pass that in as environment variables. So if you just use bash and access the env command line tool, you see here, for example, the history ID. So this is the unique identifier for your history. You see the remote host, and somewhere should be the API key. That was your API key. Oh, sorry. Here. So this is how it works. You pass them in as environment variable. You can use them. We have also pre-configured objects that. So the Galaxy connection. So there is just an object which. So if you're familiar with BioBlend, there's this GI object, the Galaxy GI, whatever, that establishes the connection to Galaxy via BioBlend, and this is just an object you can access. You just reuse that and do whatever fancy stuff. You can use some workflows from inside Jupyter if you want. Okay, so I was able to execute this. So then, I guess we can go over to a more complicated example. So if you import the second one, so it's my history, but you should import that. So it should look like this one. So actually now you have real data sets there. To see here, so some Curie reports, netting, BWA, merge send files. There was a real workflow that was running. We just had a look at the Jupyter notebook, then probably Anton will explain the biology behind it.
There is this simulated data. Just go ahead.
Yeah.
Okay. So this. I'm just when I was starting, I was explaining what the history is. So this is over the year I was in Arizona, and I promised my wife that I will never write grants over the weekend. Actually, on vacation, but unfortunately I violated that, and so I read this one about using Galaxy and HIV, so I have to have some example. And so what we do here is that we pulled out, this is related data, this is not real HIV per se. We have three isolates. So for example, these are samples from a single individual over some kind of a period. So three isolates of HIV. And so just like Björn was saying, we did all the heavy lifting here in the sense that we mapped them. And which made it a single BEM file. It's just one BEM file because we would reprocess today just to bundle everything in a single. And then they decided to develop a kind of Jupyter example from that. So suppose you're doing this and you map everything, you have the BEM file. It's not a very big BEM file because HIV is it's not the same way. And you want to know coverage for each of those isolates. Actually, in Galaxy, there is really no tool which will graph coverage. And so, it would be nice if you can go ahead and plot coverage for each of the isolates. And so, here's the Jupyter notebook that does that. So, before I sort of start with that, I'm going to just expand on some things that Björn was saying. So, basically, it's interesting, you know how sometimes the old things, they get out of fashion and they become fashionable again? I think what we do here with Jupyter and Galaxy is that we make command line fashionable again. This we're making it, it never went out of fashion, never existed. But in this case, you're essentially getting your own private machine for free, where you can do whatever you want to install it. It's one of the big benefits of this one. And I don't quite, so I represent the kind of a not very sophisticated biologist kind of distribution. So I'm not that complicated. So what I was doing here, and let's see what I can do it really long. So when I wrote something like this, I will actually restart kernel and I'm just going to erase everything. So start. Just like Björn was showing you, I'm just getting data set 20. In data set 20, in this particular case, it's a BEM file. So it's probably not something you would like to be doing with, let's say, 1,000 genomes BEM files. But in this case, it's just fine. It's not very big. So I'm getting this thing here. So it will get the data set 20, so it sets it on the file system within that buffer container. Of course, 20 is not a very descriptive name. So what we're doing next is I'm just moving it to a different file, which I call HIV mapping. Now, it's a BEM file. I want to build a read depth distribution for individual read groups within that. So I actually need samples. So I need to install samples. Fortunately, the Docker container which you're starting out here is configured with Honda. How many of you heard of Honda? So some number of you. Basically, it's one of the fashionable package managers, which works really well Whereas, for example, not really linked with Jupyter, but we're trying to essentially rely on Conda for all the tool dependencies. So I will use Conda to install SAMtools because I can, of course, install SAMtools by going to GitHub, getting it from there, making it, compiling everything. Then you just install it from Conda. So for this, I need to configure Conda channel. And you can see that in this notebook, I have that markdown cells where I describe everything. So that these are the hyperlinks which you can click on. So I'm configuring Conda, and I'm adding BioConda channel. It's a biologically relevant channel where there are lots of recipes for installing biomedically relevant software. And I'm installing SAMtools. And all you really need to do is you just run Conda and install SAMtools. When you use Conda from Jupyter, you need to use that why option, so it doesn't ask you questions, proceed or not proceed. It just tells it yes. So we're installing. I don't know how to use this computer. So I don't know how to scroll. I'm just doing it. So install everything. So at this point, really, all we've done, we've put in this band-aid set and we install samples. And so SAMtools has a very useful utility as well. SAMtools command SAMtools split. What it does, it splits them on the. So I use the exclamation mark here because I'm not showing it. So I'm running SAMtools split. We'll take this time. Once it's done, we create the directory responsible for that. That's our original file. Now we have this HMNet_1 underscore 0 underscore 1 underscore 2. So this file is for IPython. So now we can compute coverage. The coverage we're going to compute with another SAMtools tool, and that SAMtools tool is called get. But the challenge here is that we actually split our original band into two. So now we need to compute depth in each of them individually. And so instead of doing this one by one, I'm having this Pythonic construct. And what's cool here is that so this is for loop where I'm iterating over three values, 0, 1, and 2. And I can actually call the shell command here explicitly, and this item in the curly bracket will be replaced with a number, 0, 1, and 2. So this loop will go through 3 iterations, and every iteration will produce a file called group underscore 0 underscore 1 underscore 2. And those will be the files that will contain the coverage values. And the coverage values is just position in the genome, number of genes. That's all there is here. Question?
Oh, I'm sorry. So, back you had mentioned earlier, you had just done the -5 regardless of just have if you had forgotten to do that, or maybe it was a tool you're unfamiliar with, are you able to interact and say yes or no, or is it essentially going to freeze at that point because you're not able to get the input?
Well, my experience is just it's not going to do anything, so you have to restart your kernel and nothing change. I don't know if there's a solution. It requires your But me doing that might represent the fact that I don't know how to do it. So we continue running it, so you will see that we now have this coverage files, regroup 0, regroup 1, regroup 2, and so on and so forth. And what I will do is I will paste them all together, so instead of 3 files in one file with 3 columns, 1 column per regroup. This will be done with just combination of paste and cut. And this will look like this. So that's the genome name. That's HIV genome version of it. So, lots of gene references. This is the position in the genome, and that's the coverage for each position. So all we're going to do here is to now cross the coverage. Now, you already heard the name pandas. So this is a really useful Pythonic module for dealing with essentially big data sets. It essentially emulates our data frame behavior in Python. But for those of you who don't know R, or for those of you who are starting to learn R, especially if you learned some decent language before that, there's Python. R is extremely valuable. And you know how people run. So you don't have to do it. You just depend. So what I will be doing, I'm importing pandas, and then I'm reading that file that I just generated, data frame in pandas. Essentially reading that file all covered for regroups that generated the header. And pandas. Reading it, and what I'm doing here, I'm setting the column names for the first column, reference positions, and lengths that will be C. In pandas, it will look like this. Very much our data. And finally, I'm going to plot it with matplotlib. So my coverage is actually pretty good. Just to kind of get this edge in there. But so I have sample 1, sample A, sample B, sample C, so the coverage is fairly even. If you have users before, probably what I'm telling you is horrifying, because we are here preaching to you that Galaxy saves from the complexities of command line, and here I am using for loops. But you will never be able to escape that, because ultimately, I always envision this data analysis, but it's like a tree. The Galaxy takes care of the trunk stairs. You have trunk, it reads, and branches over into big branches. You have our identity, things like that. But at the end of all of these branches, you eventually end up with these limited data sets which you need to interpret. It's not something you can publish. You're publishing the leads. So to get from these intermediate branches to the leads, you will need that. And what Jupyter Integration Galaxy does is bring it all into one place and more things. And you can sort of play with the data at Galaxy Infrastructure's expense, which is great. That's kind of a simple example of real data. More sophisticated examples, for example.
Wait, show where they are.
It's worth the French people. I don't need them.
I learned that the notebooks have been Python 2. There's no limitation, right?
Yes, so Jupyter So yeah, Jupyter supports many different kernels.
We're all pretty familiar. I guess our
Exactly.
I just want to make sure you can use the Python.
Yes. So we have a few pre-installed kernels. We don't have all 26 or 27 that are available. But essentially, what I told you before, you can set up your own image. So if we are missing a kernel, just create your own image or contribute to our image, and we will rebuild it. We have we have a Haskell kernel. We have Python 3, Python 2. We have the R kernel, and Julia is included. But for example, the Perl kernel, I was not able to get installed. But yeah, if you have your own kernel, if you have your own environment, you can just specify this image and take just another image. That's it.
One thing Björn did mention is that you can use Scratchbook. So what this does, real there. Start in a model like this. So you can still go back and forth between the Jupyter interface and Galaxy without losing that. So you can go back to that interface. And you can go back to the and you can have
It's not a very good connection.
several.
Let's see if I can, yeah.
So I'm just going to show you some results. So I had RNA secrets, I mapped them, I did, I counted the reads, and then you can actually use, and then I wanted to do some of the DEC differential expression. I didn't do differential expression, I just normalized the count. There is a DEC in Galaxy itself, but by using it in Jupyter, I'm able to build small statistics from this. So here you can see this notebook was actually built by, I took the DEC manual and I started typing commands from that. Things here, but eventually, my normalized counts without local transform, my counts with local transform. Very good. And the dispersion our local analysis correct for that. So the genes with low counts don't have approximately the same amount of variation. So again, it's shareable. So we can other. So let's go a little more. So any questions?
Last time you showed out the R, is that
So this is an R. When you use R here, you use R method. You continue in ways your model extension. And then you can just do receive your command with that. Before going to switch to our kernel.
These notebooks, you will always have them embedded in a workflow, but what if you just, like, in R, when you do an R down on markup mode, you can run it and then it'll output or another format? Is there any way to do that in your work? You send out just a format that has everything run already and all the plots in it?
If you use our studio, then yes. But our studio is another interactive environment.
Right.
It's not on main, it's maybe just easy to remember.
So Jupyter, you could put out, you could put out a final copy. Under file, you could be able to.
Oh, you want to output it, then
Yeah, like a couple, like, say,
Okay.
you just wanted to send your talk to somebody,
Okay.
not send the whole work.
well, you can just commit it to GitHub and share the repos. GitHub renders all of this.
Or you can use the download apps.
So that goes to a history or?
I wonder where would it then go? Let's try something that's never been tried. Everything explodes. Okay.
So download it.
Let's see. It's closer. You're probably a little bit stoned away because we already have 3 of those workshops. So anyway, you have anything else to
Questions?
Not ready to
And this is just our way where we would like to see really integrative, interactive environments happen. So we are using it also in part for teaching actually now programming in Galaxy. So we will give our Python courses in these interactive environments because it's cheap to set up. You get the root environment for free, you can do whatever nasty things you want. And we're teaching our students like that, and we distribute code or code snippets to our users, to garages that are not familiar. So this is our use cases. I've seen a ton of other use cases because it's so flexible. As I showed you the Finch DE or something that is completely different. It doesn't have anything to do with programming, but just a different way of writing interaction for visualizations, for really complex visualizations. I'm ready to hear, or we are ready to hear for new use cases or great web applications, which makes sense to put in Galaxy or not, I'm not sure. If you have any kind of question, technical ones, biological ones.
There are also some rough edges. This is very complicated. So there are some rough edges. For example, the half-life of this notebooks, half-life of containers is 2 hours. So save it. They just die. And we haven't figured it out yet. So it's improving every month. And another, this shows fairly sophisticated example. Sometimes you use Galaxy and you have some stupid text file, and you just want to do some simple operation. Now you can do that. You can just start this and do their whatever graph on something. Maybe it's not the ideal use that example. So for me, this is really one of the most exciting things that happen.
So if you had a class and you were teaching basically Python with the Jupyter Notebook, and you were using Galaxy to work, could you kind of impact that? So you had 40 people in your class.
So we have our own instance where we're using that. But you could use Galaxy. I mean, seriously, I don't know how many instances of your Jupyter Notebook you can start. It's surprising that it works for all of them. This is really awesome.
Okay.
It's just scaling. So that I use Galaxy.org does a fantastic job to set it up. I know for my instance, we can run roughly 20 notebooks in parallel because of this one cluster that serves index one. But for us, it scales nicely, and everyone gets its own encapsulated environment.
Yeah, I don't know how many we can start, but this is sort of, we also had a hackathon now. So one of the things that enable proper distribution. We start both with the containers. But this is actually one of the things that we want to use our location Jetstar for. start as many of them as possible. So if you're running a class with 40 people, it's not going to impact how the jobs are done, because it goes to a completely different source. It's not going to, somebody on PWA jobs is not going to matter. You don't know if that's the normal. Or you have no problems. Pretty good for now in the case in the test phase, yes.
You have the Docker engine running behind it, right, in order to run this from the Galaxy, from Docker container. How did you install it, from a loop LVM or a direct LVM?
Again, on what VM?
Loop LVM or direct LVM? Because you remember I had this problem last month when I wrote you, and it said that if you want to have a Docker installed for a production environment, you should go for what's called direct LVM. That is, you have to have a special partition for that. Probably it has to do with the OS as well, where you
So
install
I
it.
can tell you how this is set up. I don't know what virus.
When you have like /dev something, where you install it, and not on var lib Docker.
Yeah, because it will fill up, right?
Yes.
Yeah, the same way to do this is just to simulate from varlib Docker to that place that you prefer for it. And then you can choose a layered file system which matches your system.
But do you run it from a file or from a loop file?
No, I mean, you can choose a partition for it if
Okay.
you want to separate partition, but if you have another partition that has a lot of space,
You can put it there.
Simulate.
Okay.
There should be a global Docker settings in Docker where you can set this. So you don't need to.
Yeah. It's also, yeah.
So still, because there are some guys that say Docker is not safe, and it is up to discussion. What we are doing and what actually Galaxy is also doing, we have a prepared cluster, whatever, and own VM, the real VM, which is running the Docker container inside. So even if the user breaks out here from a Docker container into the host system, it's still in the VM where you don't can access anything. So you can build these layers and the infrastructure, and they won't be mostly Erica integrated, can be secured in this way that you can run these complicated setups. And your cluster doesn't need to be in the same state and somewhere else like use case you don't do.
It was more about scaling, not about security. Question.
So scaling is also, I mean, there were pull requests a few weeks ago that used Docker Swarm or can be used for Docker Swarm in the background to scale to distribute interactive environments. So try to break it. We are happy to fix it.
Someone uses Swarm.
Use case at work is slowly migrating the Swarm to only for interactive environment. It's also needed for that.
Swarm is not safe.
Yeah. Any other questions?
So basically any Docker container, Docker image can be used, and you get protocol could use part of one line. Or because, for example, if you have some image that runs through.
So I mean, this is just, I mean, if you produce some kind of web content which you can display in the browser. So that's, I mean, it's
Yeah, but what are the limitations? I mean,
Any web service, like the restriction is for one port. What you can do is you can say proxying and edit it, and get it down to one port, then you'll do that. So we cannot support talking to 2 to 3 or 4 ports or different domains or anything like that. So multiple containers will help, and certain services which have been architected to run under a proxy can be very painful. Get some point of our studio there. It doesn't always plainly say when it's being put under some path at the end. So there are some technical difficulties.
But then, if you want to run multiple interactive environments within the same Galaxy instance and the same machine where there's the same Docker engine.
Yeah.
Then how do you manage mapping to different ports? Is it something that you manage in the Docker command within the
Use the dash capital B5. We have Docker randomly choose ports first.
but you manage this automatically, so the user doesn't have to worry about it.
No, not at all.
So if you run 10 instances of the same container, you run each one on a different port.
Yep. That's all transparent.
How about Shiny?
Video in our studio is a bit healthier. Let's use some Shiny. That would be nice though.
And we accept pull requests.
Yeah. There's a new for J container from the bench as well from the group from South Africa. What else do we have?
Yeah, the more PEM IO bio stuff, IO bio stuff, so they have the Gene IO bio. Yeah, tomorrow we'll develop a hello world something. But if you have ideas, if you know good web services, whatever, just let us know. Try to create them. Okay, I think we are early, but we deserve a moment. Okay, thanks for listening.